So in example 3, we have a parking area that is being built next to a road. We can see that in the picture there. The developer has purchased 340 feet of fencing, determined the dimensions for the parking lot that would maximize the area, and then find the maximum area. So there's two different things we're doing here. One thing is we're finding dimensions, and then another thing is we're actually finding the maximum area. So when we look at this picture, we see that there's a road on one side of the parking lot, so he does not need to actually put fencing on the side that has the road. So he's only going to be fencing in these sides here that I'm outlining in blue. So in terms of fencing for the perimeter of this of this parking lot, he only needs x plus y. And he has purchased 340 feet of fencing, so all of that will be equal to 340. So I'm going to simplify that. We have 2x plus y equals 340. But that equation deals with the perimeter of this, and we were asked to maximize the area. So now let's talk about the area of this equation. I'm just going to call the area A. Area is equal to length times width, which is simply x times y. So we want to maximize area. We have seen in a couple of examples now that maximums occur at the vertex. But the problem is the way the area is the way that the area equation is written right now, it is not written as a quadratic, so we can't find the vertex of it. So we first have to make our area equation quadratic. And how we do that is instead of writing the area in terms of two different variables, both x and y, we're going to write the area with only one variable, with only the variable x. So I'm going to take this equation for fencing, and I'm going to solve it for y by subtracting 2x from both sides. So I see that y is equal to 340 minus 2x. And then I'm going to take this expression for y, and we're going to plug it in there for the area. So now we have area is equal to x times, instead of y, I will be writing 340 minus 2x. And now we can continue simplifying this area equation. We would have 340x minus 2x squared. And just to help it look a little bit more familiar, I'm going to write the negative 2x squared term in the front because we're used to seeing the x squared term in the front. So now that we have an equation for the area that is a quadratic, we know that this function is going to open downward. And I know that it's going to open downward because a is negative 2. If it opens downward, then it has a maximum right here. It has a maximum value x. Oh, it happens at the maximum happens at an x value, and it comes out as a y value. But in this case, our y value is area, because this function is area. So the vertex gives us an x coordinate that actually gives us x, what this x should be. And then the y coordinate of that vertex is going to be what the maximum area is. So let's go on forward and find the x coordinate of the vertex. We know that to find the x coordinate of the vertex, we can use vertex formula, which is negative b over 2a. In this case, our b is 340. That's the number in front of x. So we'd have negative 340 over 2a, and a is negative 2. So we have 340 divided by 4. The negatives will cancel each other out, and we get that x is equal to 85. So let's go ahead and find the answer for the dimensions, because the dimensions are going to be x by y. We already know that x is 85, so I have 85 feet by, we need to figure out what y is. Well, we do know that y is equal to 340 minus 2x. So y is equal to 340 minus 2. Well, now we know x is 85, so I'll plug in 85 right there. And 340 minus 2 times 85 is 170. So here's our answer for the dimensions, 85 feet by 170 feet. And the second part of the question that we were asked to find is what the maximum area is. The max area is going to be whatever this y coordinate is at the vertex. And we know that to find the y coordinate of the vertex, we take the x coordinate of the vertex, which in our case was 85, and we plug it into the function. So I'm going to be plugging 85 into the area function. So I have negative 2 times 85 squared plus 340 times 85. So let's see what that gives us, and then we'll check that. Negative 2 times 85 squared plus 340 times 85 gives me 14,450. And this unit would be feet squared, because we're talking about area here. 14,450 feet squared. But we can verify that, because if that is the max area, then when I take my dimensions of 85 and I multiply them by 170, I should be getting this max area here. So to check it, taking 85 and multiplying that by 170 does in fact give us 14,450.